So if you are interested to look at the rest of my portfolio, go to my website. Okay, this is people is people, but utm.my is Malaysian / Niza Sarmin. You are welcome to be my Facebook friend too.
Oh.
Also Niza Sarmin. But make sure you don't put cartoon space, yeah? Then I will not recognize you. At least I can see that you are from Ailanga or Indonesia. Then I know, because I have so many requests that I don't even know this person, and they don't put real names, they don't put real face, because my Facebook is more to my working activities with students, international office activities. So if you want to see, your face will be in Facebook in few days. So if I did not accept you, you send me a messenger. This is your name. I'm from your class, IndoMS school. So I will accept. Then you will see so many activities here. But sometimes I got crazy too with food. So all right, so we continue. Just now, done with group theories, just the basics to make sure that you remember what you have learned before, or probably you have not seen some of the group presentation. The second one is graph theory. I'm sure you know graph. Just put some introduction to graph earlier. You know about complete graph, right? Complete graph. How do you say in Indonesia?
Graph lengkap.
Graph lengkap. Lengkap. Okay. So I think in Malay also, in which all vertices are connected, yeah? Okay, next we go to multipartite graph. How do you say it in Indonesia?
It's kind of the same, multipartite.
Okay. Multipartite. Okay. Okay, so this one we denote as this, right? K and 1 and 2, right? Until like and M. Okay, so we partition the vertices into the M subsets, right? And for those vertices subsets, then all what we say, the vertices are all adjacent, right? For that particular subset. We will see this a lot, all right? Next is degree of a vertex. Degree is what?
Derajat.
Darjah. Because in Malay also we call it darjah. Darjah bagi. Oh, now I remember. The vertices is in Malaysia, in Malay is bucu. So yours is titik, right? So we call it bucu. Okay, so the degree of a vertex is what we will be counting for the indices, right? So we call this the number of edges, right? So the degree of V is the, sometimes we use this as the number of edges at the vertex V. Okay, next we need to know about the distance of two vertices. Okay, the distance of two vertices is the shortest path from VI to VJ. Shortest. Okay, then we will be counting this. All right, now let me just draw quickly to make sure you understand. Okay, this is C, A, B, D. How many vertices that we have?
4.
4 vertices. How many edges?
5.
5 edges. Okay. Now, what is the degree of the vertices?
3.
3. Degree of B.
2.
Degree of C.
3.
Degree of E.
Also 2.
If we say easy, what is it in your language? Gampang.
Gampang.
Mudah.
Mudah.
Mudah. Senang. Itu bahasa Melayu. Okay, now look at the distance. Yeah, the distance. What's the distance between A to A?
0.
0, yeah? So B to B, C to C, oops, E to E, they're all 0. Okay. Now what's the distance between A to B?
It's 1.
1. Also A to C, right? Also A to E.
A to E.
All right. So A to B is 1, A to E is 1, A to C is 1. The one that is not connected is B to E, right? So the distance of B to E is
2.
2.
right? So you see, if it's connected, the distance is 1, right? To itself, the distance is 0. If it's not connected, then you have to go from the other side. Okay, senang, mudah. Okay, now before we go into indices, I want to just go back to the definition of 3 graphs, yeah? 3 graphs. Okay. So the first one is the non-commuting graph given by Dr. Intan, yeah? Can you define this? I use this, okay? The non-commuting graph. What is the vertex? Is G minus the
center.
Diameter.
minus the center. Sometimes we write like this, right? Sama juga, okay? Without the center. Because the edges is X is connected to Y. X is adjacent to Y, right? Sometimes we put like this, if and only if XY is YX, right? But the Intan has gone through this. So that's why we're taking out the center, the center, because the center commute with everything else. If you don't take out the center, then you get connection, right? It will be connection because it's commutative. All right. Did you see? Did you find the non-commuting graph of S3? Ada tak Dr. Intan bagi contoh? Example, non-commuting graph of symmetric group of order 3. Yes or no? You know the question? The non-commuting graph of symmetric group of order 6. Yes or no? Vidya?
Yeah.
Have you seen this graph or not?
I have.
You have.
Yes.
If you have, I am not going to give it.
Maybe just a little bit kind of like explanation to maybe for us to remember.
Okay, so you know S3 symmetric group of order 6, right?
1 3 2 3
1 2 1 3
2 3 1 2 3 1 3 2.
Okay, so if you do minus the center, this is the center, right? These are the only ones. This is the center. So if you have 1 2 1 3 2 3 1 2 3 and 1 3. Okay, then the non-commuting means just now is commuting. The non-commuting is don't commute, right? Don't commute. Okay. Okay, so the one that don't commute, wait, the one that commute is only these two. The only one commute, okay? Because there is no identity. So the rest, they don't commute, right? Only this one that commute, yeah? So this is the non-commuting graph of symmetric group. All right, okay. Now, I want to give this non-commuting graph of dihydrographs. You all know that S3 is isomorphic to D3, right? Symmetric group of order 6 is isomorphic to dihydrographs group of order 6, right? So this one is reflection, right? This one, they are reflection, and this one rotation, right? So 1 to 2, 2 to 3, and so on. So actually, they are isomorphic too. That's why they are isomorphic too. The rotation and reflection. Okay, so I want to give you the formula for the whole dihedral group. Okay, so we will use this later on. Okay, it's K1, 1, 1. This is n times. Okay, n minus 1 if n is odd. And 2, n minus 2 if n is even. And how many times if this 2 is n over 2? Right? We always have to separate odd and even. If you remember, this morning, I shared about the center, right, of the dihedral group. Right, when you take out the center, you have to separate odd and even. Also with this. So when the case D3 is D6. D3, D6, this is n is 3. So when n is odd, n is 3. This is K1 n times, right? 3 times. And then 1, 1, 1. That's why you have okay, right? They have this 1, 1, and 2 here, right? For this one. So we match with S3 and D3. All right. Okay, now, okay, this is for just your own homework. I'm not gonna give like assignment, but try to find, maybe on Thursday I will ask you. Okay, just write on a piece of paper. Maybe later you can share on Thursday. Find this, or maybe you have done this for Dr. Intan's class, but just sorry. Yeah. Find the non-commuting graph of D8, because earlier you have seen D8. Don't use this. That's cheating. Use the vertices, right? And then you can check when n, the case n is even 4. You know already the answer, but just as a good exercise, right? So you know the answer is already 2, right? Over to 2, 2. I already gave you the answer. All right. So next is I will give you the non-commuting graph of generalized quaternion. Okay. What is the just now Q for n, right? Q for n. Did you see this in the Intan's class or not, Nidia? The generalized quaternion.
Not yet.
Okay, if she didn't give it, I will give it. It's just simple. This is K, 2 to the n minus 1 minus 2. Okay, and this is 2 to the n minus 2. Okay. Some of my previous PhD students got some of the results that I share with you today in the class, but I didn't get to put the references. If you go to my website, all my previous publications, they're all there. So if you're interested to see any of the details of any of the results for any of the topic in group theory, and I also do some with the NA computation, you can find the paper there, yeah? Okay. All right, so this is the non-commuting graph of, this is this is for quasi-dihedral, yeah? Sorry. This is for quasi-dihedral. Wait. This Q for n is different. Okay, it's Q e to the 2n, right? Sorry for that mistake. This is for C. So I need to find the generalized quaternion. Okay, so the non-commuting graph, for Q for n. So this is now the generalized quaternion. Right. Okay. So this is much simpler actually. Okay, and this is n times. It's 2n minus 2. This is 2 to the n minus 1 minus 2. So you can match and get the result for the general one. Okay, I have to move on to the number of conjugacy classes. So I need to list the some number of conjugacy classes and find the conjugacy class graph, right? Before we move on. So this is the first one for all. Now I will list the conjugacy class graph for all. Right. So the first one is conjugacy class graph. Is this the first time you see it, Nidia? You have never seen it before?
In what, the conjugacy class or the
conjugacy class graph?
Oh, yes, this is the first time.
Conjugacy class graph, Sesi, yeah? Conjugacy class graph is a graph in which the vertices is the set of non-central conjugacy classes. Okay, non-central conjugacy classes, meaning the conjugacy class which contains more than one element. The central one is the one that contains by itself. And two vertices are adjacent. Vi is adjacent to Vj, if and only if and only if they have a common, they are not relatively prime, they have common prime divisor. Okay, so you can try to find exercise I think maybe this one is for our tutorial. We have tutorial after this, right? So we reserve this. I give you now the question. Find the conjugacy classes of D8. Okay? Okay. Is that the question? Oh, it's different. The question here is different. Letter is different. Let me give you this. Okay, let me give you the conjugacy classes. You remember? Earlier, I give you this. The one with E. Wait. I give you this, right? Yeah. The one with R19. The one with H. H is the one with D, right? 1, 2, 3, 4, 5. Okay. Yep. So this is only this. This is only this, because this is the center. This is these two, right? And this is this H and V, and this is D and D prime, right? So this is the central one, this central one, only one element inside. So this is not in the vertices, so we have only 3. So this is 1, 2. I shouldn't put the edges yet. 1, 2, 3. So maybe we call it this like this. Okay. So this the modulus, the order is 2. The order is 2. The order is 2. So 2 and 2, it's 2, right? The greatest common divisor, which is not 1. So they can be connected. So that's why we get complete graph. Right? So it's clear, yeah? So it's a complete graph. All right, so this is the conjugacy class graph. Now I just quickly give you the formula that you will use later for the 3 groups. All right. The first one for D to N. Okay, for conjugacy class graph. This is found by my student actually, on PhD student. Okay, it's the union of the complete graph of order n-1/2 with the conjugacy classes of B. Okay, what is A and B? It comes from the presentation of the Dihydrographs earlier. Okay, this is just the complete graph of order n/2/2. When n is even, we have 2 cases. When n is even, you break up into 2 cases. One, if n is even, and n/2 is even. Another one, if n is even, n/2 is odd. Like 4, right? 4/2 is 2 is even. 6/2 is 3 is odd. So it depends on this, and this is equal to k n-2/2 union k2. Right? Now for the next one, okay, for the next one, find the conjugacy class graph of Q for N. Generalized Quaternion group, right? Again, it depends on the formula of the conjugacy class that I give you earlier. So from that cases, then you get this graph, right? So this is K n-1 union K2 if n is odd, and K n+1 if n is even. Okay, and the last one would be for quasi-dihydrogroup. So the last one is quasi-dihydrogroup. And this one is just equal to K 2 to the n-2 plus 1. all n bigger or equal to 4. So you have that because also of the conjugacy class earlier. All right. Now my last graph that I want to mention in this scope is, I see somewhere in your lectures that you study about coprime, is it, Lydia?
Yes, yes, we are.
If the order of both vertices are coprime, right?
Yes.
Yeah, okay. So for this one, I just give you the answer then, yeah? Okay, so coprime graph is a graph, the vertices are all elements of G, right? You don't exclude anything, and then you just connect if the order are coprime, right? Okay. Now for this, we want to put, let me just put this co for coprime for D2N. Okay, so this is K1 n minus 1 n, right? If n is what? Okay. Co-prime graph of dihydrogroup when the case n is odd prime. And this is equal to, so this is a multipartite, right? You call it, okay, multipartite graph. And the other one is equal to K1, 2 to the K plus 1 minus 1 if n is 2 to the K. K positive integer. You see, you're missing some of the even numbers because they cannot generalize this. Okay, tak boleh dicari secara umum ya. This is a star graph. You know star graph, right? Graph apa? Bintang ya?
Bintang.
Graph bintang. So this one is isomorphic to a star graph. Okay, last one would be for generalized, quaternion, and quasi-dihydrographs. So now you learn one new one, right? You learn about coprime before already. You learn about non-commuting already. So the new one will be conjugacy class. Yeah. Okay. So the coprime for the generalized quaternion group. Okay. This is isomorphic to a star graph. This is also 1, 2 to the K plus 1 minus 1. When n is 2 to the K minus 1, K bigger equal to 2. Okay, this is for the quaternion groups of order 4n. We see there is a similarity because even the groups, they have some similarities in between the presentation. 1, star graph, yeah, 1, 2 to the K plus 1 minus 1, like that one. And the last one is coprime graph of Q D to the quasi-dihydrogroup, right? And this is also isomorphic to a star graph, 2 to the n minus 1. Okay, how many are here? I can see only Nidia. 1, 2, 3, 4. 21. Why it's already reduced? Zaida is not here, it's okay. Okay, now is the time. Still have 20 minutes for this. For topological index, our first one. Yeah, okay. We are ready for our topological index. Okay. Topological index is a number, right? It is a number. It is a numerical value. Nilai numerik. Tak tahu bahasa. So this actually can a numerical value that can be calculated from a two-dimensional graph. So why a two-dimensional graph? Because a graph that represents a molecule. So topological indices are normally a numerical value found by chemists, ahli kimia dengan molecule, yeah. So this information from a graph is converted into numerical characteristic for this particular one. So we have somehow a molecular topology, and there is a molecular property from the molecules, and we get a number. And why this is used by chemists? Okay, why this is used by chemists? Now, because they want to find, like, for example, boiling point somehow. So if people ask why we are studying about topological indices, chemists use this. And this is much simpler than really doing it and boiling it and using all those experiments. Yeah? And they use the degree of vertices and the distance. So degree, distance, they're all in the part of the formula. And who introduced the first topological index is called the Wiener index. Nidia, you wanna guess who introduced this index? What's the name?
Winner.
Winner. And you are the winner.
Oh, amen.
So this is introduced by Wiener in 1947. Yeah, he introduced this Wiener number, and he compute the boiling point of alkanes. Right? You take any chemistry class before, like in high school or in university, or not?
Last time in the first semester, so it's 3 years ago.
But it's okay. At least we know there's such thing as chemistry, right?
Only the numerical.
Okay, so this is the main application of this. Now, we want to see about the Wiener index. Yeah, the Wiener index. Okay, so we want to let gamma to be a connected graph. Nidia, you can screenshot from there, right?
Yes, yes.
Take some screenshot, then you email me later. Then I put in my Facebook. This is how the Indonesian students see the class in UTM.
All right.
This is my, anyone that take
NHS. Is it? It's not really clear.
NHS.
Oh, NHS.
My name.
NHS MY.
Okay, so let gamma be a connected graph with a vertex set B gamma. Say we have 1 until n. Yeah. Then the Wiener index denoted as, of course, W, right? W of gamma. This is actually half the sum of the distances of every pair of vertices. So we write like, because we wanted every pair, right? So we go I from all the indices and then J from all the indices. N. I want to change this to N. Okay, I from 1 to N. Where Bij is the distance between Bi and Bj. Let me try to see myself from the speaker view to make sure, yes, I can see my writing. Otherwise, we call it like short sendiri. Short sendiri means you just do it no matter what people see or not. Okay, so I think this is clear, right? Just now we have looked at what is the distance between two vertices. So you change the j first. So you go like I1, I2, right? And then you choose the I. So you choose one I, say you start from I equals 1, then you go through all the j's. Then you raise 1, meaning every single pair, you have to count the vertices. All right. Okay.
Professor, just to be clear, is it the shortest path for every two
this
vertices?
is how we define the distance earlier, right? The shortest.
Oh, yeah.
Yeah.
Okay, thank you.
Okay. Now, let me give you in-class exercise. Later on is our tutorial is different. This is in-class exercise. To make sure all those students, they are here or not, I don't know, I just see the name. At least the ketua kelas ada ni, dia is there. Okay. Okay, so I give you this graph, yeah? But this is 5. So 1, 2, 3, 4, 5, E1, E2, E3, E4, E5, E6. Okay, it has to be connected, yeah? That's why in the winner, the definition is given for connected. Okay. Now, calculate the winner. So now, this J1 until 5, right? I1 until 5, D of I, D. I give you 3 minutes. 3 minutes. How many times you have to calculate? 5 times 5, 25 times, right? Don't forget the 1/2 outside. Okay. So the first one will be like D11. This is the first one, right? And then you have I equals 2. Then you add this until, then you have 3, 1. Then you have 4, 1. Then you have 5, 1. Until at the end. Okay, and then all this. Okay, as one example, take this one. So I take this side. So 1, 1 is 0, right? 1, 1 is 0. 0. 1, 2 is 1. 1, 3 is 1. 1, 4 is
2,
2. 1, 5 is
3.
okay. So this one is 7, and then give me the answer.
I get
15.
30, all of them.
What's the answer?
I get 30.
I got
30.
15.
30 will be
Oh.
15, yeah?
Yes, like that.
Okay. That's correct. A plus. That's quite easy and straightforward, right? Okay. All right, I will give you the winner index of these three types of graph for the three type of groups. Okay, so we have those. Will not give the detailed proof because that will add up to our class to maybe 1 month. I'm just kidding, but just give you the okay, I think this is clear. Yeah? I can give you any type of graph, then you can see, then you can start from 2 for this one, right? So 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, and so on. I think this one is straightforward. Once you get the graph, it's pretty easy to get all this. All right. Okay. Now let me give you the winner index of those three graphs associated to our three groups. All right. So the first one is the, I call it proposition. I don't know why, but in my notes it's already 18. Yeah, because all those things I call it proposition. Okay, so the winner index of the non-commuting graph of the, oh, this is in general, eh? This is not yet for DN. This is in general. We can actually find the winner index of the non-commuting graph in terms of the order of the group and the order of the center for this one. So there's an easy formula already. It's 1/2. Okay. The order of G minus the order of the center, okay, multiplied by the order of the group G minus, let me rewrite here, it's too long. You don't have to erase, yeah? It's just, I want it to write in the one line. Okay. 1/2. 1/2. Okay. The order of G minus the center. Yeah. The order of the center. Okay. Multiply by the order of G minus 2. The order of the center minus 2 plus the order of G multiplied by the conjugacy, number of conjugacy class minus the order of the center. And all divided by 2. Oh, okay. There's a proof for this one somewhere. So we have to multiply all by 1/2, but take the order of the center, subtract that from the order, multiply by 2 times the order of the center, subtract that by order of G and 2. Then we take the number of conjugacy class minus the order of the center, multiply that by the order of G. So we got to this theorem. If actually you want to do this in general for the group, a big group, you imagine how many times you have to take the double summation, right? So they come up with this proposition. So the winner index of the non-commuting graph of D to N, okay, again, we have to separate into 2 because just now, even the conjugacy class, the center, right, we separate into 2 cases. So using that, then you can prove that putting in this in here, you get this. Okay, and 1/2 get a number, right? This is a square, multiply this, you get a number. When n is odd, then you get some number. When n is even, you get some number for the winner index for this particular graph. All right. I give the proof in the notes. You can go through the proof. Okay, it's quite straightforward by substituting whatever I gave you earlier, right? There is the order, there is the center, there's the conjugacy class. This morning, you plug in, you will get directly these two. You should try that out yourself and just to write out and see. It's pretty straightforward. All right, and you have to do two cases, yeah? Or n even. The next one would be the winner index of the conjugacy class graph for dihydro. Oops, I don't want to erase that, but I did. But anyway, let me call theorem 2. Okay, I'll finish this and then we take a break for 10 minutes, right? For the last one. I mean, the 15 minute is like, why is it very, very fast? I don't know why. Maybe is it my watch or it's real? Or because I'm standing, I don't know. Okay, so this is quite short, yeah, of the, what is this? Okay, this is for the conjugacy class graph, yeah? It's just straight this, okay? And also I give you the details of the proof. How do you get this? By definition, okay? By definition, you can figure out the distance, okay, of the dihydro group for the conjugacy class graph, all right? Okay, and then we have the winner index of the co-prime graph, all right? So the winner index of the co-prime graph of the this one depending on, this is when n is odd prime. Okay, this is when n is odd prime. The winner index of, yeah, for the dihydro group when n is odd prime. Okay, so there is also the winner index of the first graph for the second group. The winner index of the second graph of the second group, the winner index of the third graph of the second group, and also the third round would be the winner index of the first graph of the third group, okay, and so on. So this one, I have to stop before we go to our tutorial. Is that all right, Nidia? You are the class monitor.
Yeah, that's totally fine.
Okay, take a break of 10 minutes, yeah?
Okay, thank you.
Okay. All right. Okay. Okay. Are you here, guys?
Hello, hello,
Yes, Prof.
Professor.
Can you just show your face, everyone? Just for 2 minutes. Boleh ya, betul-betul ke rambut, makeup, tudungnya. Okey, baru nampak. Oh, tudungku sengit. Ini semua rambut MCO ya. Kalau di Malaysia dipanggil PKP. PKP apa? Movement Control Order. Apa ya PKP? Dah lupa dah bahasa Malaysia. PKP pun dah lupa. We are still under MCO actually. Sebab online, right? Online class. So some students they are just don't think they need to turn on the video, so boleh aja baring-baring sambil ni ya. But it's nice to see everyone. Let me call your name, whoever is here. Yeah, I have called Nidia, Putri, Andini for many times. Sharif juga, I call your name. Akbar, Zaki, Rambu, Maya, yeah, Rizki. How do I say your name? Wanha, Sonia. Apa itu?
Anwar Sania.
Okay. Ananditya?
Ya, Ananditya.
Ananditya. Okay. Apa tu? Karina.
Karina.
Karine. Okay. Clarita. Okay. Nikita. Ya. Betul. UGM ya. Saya pernah sampai UGM. Sri Nurhayati. Ada? Oh, Zahidah ada hari ni. Petang ni. Okay. Lailatul Maghfirah. Right. Dwi Nurul Istiqomah. I know Istiqomah is in Arab. So
Yes.
Shadam. All right. So, okay. Now, I already actually uploaded the tutorial. It's okay, Zahida, it's okay. Sometimes we are there, but we are not here. I understand. So I already uploaded actually this tutorial. The tutorial one is on the winner index of conjugacy class graph of dihedral group of order 10. So I just take one because we now only know winner index, right? Winner index, we take one, the second graph, conjugacy class graph, because you have learned about the non-commuting and the other one, right? And conjugacy class is new. So number one, find the conjugacy classes of D10 using, well, if I ask you to do it using definition or proposition, but you can use anything as long as you find the conjugacy class, yeah, of D10. Okay, you can use A and B, right? So D10 is generated by A and B. A to the 5 is B squared is 1. Okay, use that. And we also have a proposition how to find the conjugacy classes of D2N. You can actually use that. Okay, for B by using the result in A, sketch the conjugacy class graph of detail. Okay. And the second question, prove that the winner index of Kn is 1/2 n minus 1. Okay, prove that the winner index of a complete graph of degree n is 1/2 n minus 1. The third one is compute the winner index of the following molecular structure. Okay. C has to be connected into 4, right? 4 atom. So C to C, and then we have this. This is actually for ethane. Etana, I think, in our language. Etana, kan? Ethane, yeah? Okay. How do you write this in the C2H what? Kan, right? I don't know, my chemistry is like so many years ago. Your chemistry, if 5 years, mine is like maybe 30 years old. So you can transfer this into like 1, 2, 3, 4, 5, 6, 7, 8, right? And this is the connection in between them. Okay, how many minutes do you need? 15 minutes, maybe? We try, ya? Ya, Akbar? Tak dengar suaranya, you have to unmute you, like you're talking to yourself. Okay, so we try for 15 to 20 minutes. I will ask whether you are done or not. Okay, then you can write nicely. Okay, after this, then I will ask someone to share. Then you can take photo, right? Take photo, then you can share screen, and then we will discuss. All right? Okay ke tidak? If it's okay, everyone, you do like this reaction. Okay? Okay? Okay. All right. If you have any question, just ask. I'm here. Media sudah sampai mana?
Number 2 and number 3, but I haven't finished number 1 yet.
Oh, okay.
I skipped the number.
Okay, okay, that's fine. Anybody got number 1? No? Yes? No? Yes? You know, if Malaysian, normally the Malay, diam tanda setuju. If you quiet means you agree. Okay, number 1 semua sudah siap? Jangan diam. Kalau belum, kena cakap belum. Okay, maybe we add more minutes, yeah? We add more minutes until 2:30. Because I want you to try. Okay, I want you to try so we see our solution. Which part that you have difficulties, which part that you do understand, which part that you don't understand. Okay, we have 7 more minutes. Actually, Nidia, I'm sitting just here. So if anybody want to call me, just shout out like Roniza. Yeah.
All right.
There is no chair here. I sit over there.
Okay. So we basically unmute our mic.
Yeah.
Okay.
Okay. Right. Any takers for number 1? Okay, no takers? Yes or no?
Only 1A.
Okay. How do you get it?
By using the where is it? By using the proposition.
Uh-huh.
So should I just say the conjugate classes?
Okay.
The first one is 1.
Mm-hmm.
The second one is A and A
Inverse.
inverse.
This is the case when n is 5, yeah?
Yes, so
n
it's
is
odd.
5, so you take the odd one. Okay.
Yes.
Case. A inverse.
And then the second
How
one
do
is
you say inverse in Indonesia?
it's still inverse.
Oh, okay.
Yes.
A squared, A negative 2.
Yeah. Then the last one
Okay.
is
The next one is still the same thing, right?
yes.
N minus 1 over 2 is A2, so it's already here. So the
Mm-hmm.
last one is
AB.
AIB, right?
Yes.
IB 0 less or equal to I less or equal n minus 1. 4,
4.
right?
Yes.
So which is equal to B,
A-
AB,
AB, A3B,
A
A
squared B,
squared B,
A.
A cubic.
Okay.
Yes.
Now you find the conjugacy class graph.
Oh.
Okay. So the conjugacy class graph, this one out, right? Okay.
Yep, it's the center.
So this one we call it like CLA, right? This is CLA squared. Then here we call it CL of B. Just one representative. Okay. And what is the order? What is the order? What is the number?
2.
2.
2. 2.
2.
1, 2, 3.
4.
1, 2, 3, 4. Right?
Yes.
Okay. So how do you draw? How do you draw the edges? The edges is if the order is coprime. If the order is coprime, that is conjugacy class graph. Okay, if the order, the GCD is not 1. Okay, so this one and this one, 2 and 2 is 1, right?
Yeah.
Yep.
Okay. What about this?
It's not connected because
It's 4. Because the number of classes B is 4,
Mm-hmm.
and the number of classes of A or A square is 2, and 2 and 5, 2 and 4 is not coprime like that.
The GCD of 2 and 4 is 2, right?
Is 2, right? Okay, yes.
It is not 1. So it is connected, right?
Yes.
Yes, it's adjacent.
It's adjacent.
Professor, can I something?
Yeah.
Why in classes of the last classes is not the 4 power is not include these classes?
I just put it there because I want to see if you see or not.
Okay. Okay.
Okay.
Yeah. Thank you, Professor.
That's the trick of a teacher. Okay, so it is not connected because this 1, 2, 3, 4, 5. I know you have 5. That's why you said just now it's not co-prime, right? So this
Yeah.
is the graph of the conjugacy class of D10 is equal to, we write K2 union just this, right? Plus of there's a dot here. So it's K2 union this. Okay? Okay. Number 2. Any question here? It's clear, right? Okay. Because Y is connected. Because a VI is connected to VJ if the order of VI and VJ is not 1. Or GCD is not 1. Or they have common factors. This one is 2. This one is also 2. So the GCD is 2, which is not 1. So they connected, or the edges, right? And this one is 5. So 5 and 2 is co-prime. This one also is a co-prime. So that's a single band. It's not. So this is not a connected graph. That's why I didn't ask to find the winner index. It's not connected. All right. Okay, if you okay, please show your jempol ya, kalau orang Jawa panggil. Tunjuk jempolnya. Jempol. Okay. Ada jempol. Siapa yang tak tunjuk jempol? I don't know, maybe you still thinking. Alright. Okay. Now, can somebody show number 2? You have, if you want to share, I can let you share. Okay, Nidia, mau share?
Actually, my number 2 is not really well written. It's better if I explain it through words,
Okay.
maybe.
All right, it's okay. So we want to find W of Kn, right?
Yes.
So if you have n of this thing, right? All connected, right?
Yes.
So they're all connected. So this is half sum, right? Sum of
Some ij. Yes.
j 1 to n, I 1 to
To n.
So next one is you have, I put this first, yeah? D1, right? 1, 1, 1, 2 until
So
1n.
1n.
Okay. Then you go 2, 1, 2, 2 until
2n.
Dot.
All the way down to
1
n1 till
and 2
nn.
and n. Alright. Okay. 1 to 1 is 0, right?
Yes.
What about the rest?
The rest is 1.
Okay.
Oh.
0 plus 1.
1
1 plus 1
1
plus 1.
Until 1 for
One.
n minus
At-
1 times.
Yes.
Yes.
Okay. Okay. And then the next one,
It's also the same.
but 1 first and then 0,
0.
right?
Oh, yes.
1 plus itself.
0.
So we move to the second one.
1 plus 1.
1 again for n minus 1 times. And we did this. So this one is 1. This one already n minus 2 times, right?
Yes.
And then you do it until n times, right?
Yeah.
Okay. So you get 1/2 n because there are n times. N
And
minus
minus 1. Yes.
jempol ke tidak jempol? To me, it's a jempol. Okay. Okay. Then this one, yeah? Okay. All right. Okay. Number 3. Okay. So this one, let me put the name maybe. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So again, I put like this. Okay, I from 1 until 8, right? J from 1 until 8. Okay. So this one you really have to count, right? You really have to count. So for example, start from 1. Start from 1. 1 to 2 is 1. 1 to 3 is 2. 1 to 4 is 3. 1 to 5 is 2. 1 to 6 is 2. 1 to 7 is 1 to 3. 1 to 8 is 1 to 3. So this is only for D1J, yeah? D1J. So this is D1J. This is equal to 16 kan? Right? 16 for the first one. And then you have to start 2. Start from 2. Okay? So this is for the first one. You have to do this 8 times. Right? So you start from 2.
1,
2, 1. 2, 1. 2, 2.
0, 2, 3,
And
1,
you put 1, 1, right? Which is 0 actually, right?
0. Yes.
There 0 here. 1, 1. Okay? 2, 1. 2, 2. 2, 3. 2,
2,
4.
4,
2, 5.
1,
2,
1,
6.
2,
7. 2, 8.
2.
Done. Okay, 1, 2, 4, 5, 6, 10. Right? Okay. Now 3. 3. 3, 1.
2,
3, 2.
1,
0,
0,
1,
5.
2,
3, 5, 2, right?
2,
3, 6.
2,
2,
1, 1.
1, 1.
and 1.
It's same.
10. Okay. 1, 2, 3, 4. 4 is like 1, right? Because it's
Yes.
Yes.
okay. 5 also, right? You will get the same. 5, 6,
7, 8. Okay. 116,
20.
88.
8.
Oh, 58, yes.
Jempol.
My bad.
Jempol, jempol, jempol. Okay. Okay, so so I hope that this first day is clear to everyone. Okay, I skipped some of the parts in which there's the winner index also. So remember, we have 3 groups and then we have 3 graphs. But I focus on the conjugacy class graph because you have seen the first one and the third one, right? In the other class, non-commuting, and also the co-prime graph. So I concentrate on the conjugacy class graph. Sometimes we don't use the definition because it's probably hard to find even the conjugacy class by formula XA, X inverse. So we come up with a proposition with the property, just use that and plug in, and then we get the conjugacy class. And you can think of, if some of you really like algebra or pure mathematics or group theory or graph theory, you can start thinking if you want to continue for masters or PhD, some topics that you can actually further. This is the beginning. You have the basic, and then you have some properties, and then you make it more general, and then you apply, and there are many applications which are actually very interesting. So I hope that today's class is clear. All right, this is how I teach my class actually in UTM. During pandemic, I use my office, And I use this board because to me, it's much better to see the lecturer's face looking at you, right? Rather than it's just small, and then when you write, you don't even see all the writings. I hope this is okay. If there is anything that you want me to improve for your next class, let me know. That is just now my email, right? This is for my name, Nur Haniza Sarwin. And we don't stop just now. Anytime, even if you want to come to Malaysia or UTM next time, can contact me. But do drop me an email before the next class if you have any suggestion that I can improve. Okay. So for the next class, we have the 3 hours for the 3 other indices. All right. We have 3 other indices. I will upload before the class, the latest the day before. Tomorrow is Eid. So to all celebrating Aidil Adha, Selamat Hari Raya Aidil Adha. So because we don't go anywhere, so I don't plan to like cook. Zahida, normally we ketupat, rendang, all those things. I have not seen my mom actually. She's in Kuala Lumpur with my sister since January, so I have not seen her for that long, but it's okay. Raya is every year, so inshallah next year we still have, but we have to take care of ourselves. That's the most important thing. Okay, if anyone wanna say something, let me just summarize today. We have seen for 3 different groups, we have seen 3 different graphs, and I shared something about the properties of the groups, so that is used to find the graph, to determine the graph, including the center and the conjugacy class. Okay, I didn't go one by one because my intention is more to the topological indices, but I want you to learn at least a new graph, at least along the way. So what we have seen today is just the winner index. So I'm sure it's quite clear, right, with this tutorial and how actually you collected. And later on, I've also shared about why people are computing these topological indices because of the boiling point of all the molecular structure of the chemistry. Okay? Anyone want to say anything? Nidia, 1 or 2 words?
For me, this is a really eye-opening class because I get to know new kind of graph, which is conjugacy class. And then also, I already learned about dihedral, Quaternion, and quasi-dihedral also, but I get to remember it again today from this class. And also, this is the first time I learned about the winner index and probably the other 3 also. So I'm so thankful to be in this class because I get to know so many things about algebra and graph.
Okay, that's great to hear. All right. Okay, Zaida, I pass to you to just close for today's session, maybe.
Okay,
Back
let
to
me.
Oh, you
moderator.
want to say something? Okay. Somebody
Okay,
else, okay.
thank you. Yeah, thank you very much to Prof. Niza for the interesting lecture today. Hope it will bring an enormous benefit to all of us. To all of the participants of IndoMS School, don't forget to join the class again on Wednesday, 21st July 2021 at 9 a.m. at the same Zoom with more interesting lecture, of course. And so don't be late. And also happy Idul Adha 1442 Hijriah to fellow Muslim. I end this with saying Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Take care, everyone. Stay safe. Okay. Assalamualaikum.
Very much, Prof. Niza.
But we will have to take one last group photo. Wait.
Okay.
Okay.
Actually, my meeting still running.
It's
We are
okay.
discussing about our conference with UTM.
Oh, okay. Okay, everyone. Just one last time. 10 seconds. Turn on your video. Okay. On Thursday, make sure cantik-cantik, solek-solek, makeup. Okay. All right. Let me give you my heart reaction. 1, 2, 3. All right. Oh, lambat sangat. Lagi sekali. Itu terlewat. Okay. 1, 2, 3. All right, guys. Assalamualaikum.
Oh.
Waalaikumsalam warahmatullahi. Baik, kepada
Sampai jumpa
bisa di
hari Rabu. Selamat Hari Raya.
Rabu.
Selamat Hari Raya buat teman-teman yang merayakan.
Saya pamit dari grup dari
Iya.
grup.
Iya,
Absen
Bu.
loh, absen. Presensi.
Jangan lupa presensi. Jangan lupa presensinya ya. Bisa di end meeting oleh operator.